This is a short demonstration of how to use the Flight Data Viewer to accurately determine if the timing between your engine's primary and secondary ignition systems is correct. This example aircraft engine has a dual ignition system. The primary ignition system uses magnetrons. The timing of the magnetrons is fixed and cannot be changed. The secondary ignition system is electronic. The timing of the secondary ignition system must be adjusted to match the primary ignition system. If the secondary ignition system fires before the primary system, it will cause unacceptably high cylinder head temperatures, a rough running engine, and poor power output. Warning: before you perform this flight test, you must adjust the secondary ignition according to your engine's installation manual and run ground tests to verify that your engine is running safely. The secondary ignition timing must be close to correct before a test flight. The flight test includes these steps: climb to a safe cruising altitude and reduce engine power to a cruise setting. Fly for around 5 to 10 minutes at a constant cruise power setting, constant airspeed, and altitude to allow your cylinder head temperatures to stabilize. Turn off the secondary ignition and fly only using the primary ignition system. Fly for around 5 minutes. Turn on the secondary ignition and turn off the primary ignition. Fly for around 5 minutes, only using the secondary ignition system. Turn on the primary ignition. The test is complete and you can land to evaluate the test results. Here is the test flight data displayed in the Flight Data Viewer. First, determine the point in the flight you are flying using only the primary ignition system. There are several ways to do that. You can use the flight time as a marker. For example, assume you turn the secondary ignition off at 10 minutes into the flight. If so, use the second column and find the data starting at 10 minutes. Another method uses the altitude bug setting. For this test flight, the altitude bug was changed from 1,500 feet to 2,000 feet just before the secondary ignition system was turned off. Scroll through the altitude bug column to find 2,000. Once you've found the beginning of the primary ignition only range, select it by clicking that row. Scroll down through the data list and find the point where you turn the secondary ignition back on. In this test, that is indicated by an altitude bug change to 2,500 feet. Hold down the Shift key and select this row. Note that now a range of rows are selected and that the currently displayed graph shows two vertical selection lines. Let's name and save this range. Right-click on the data table and select Define Range. Let's call this range First Test, Primary On, Secondary Off. Display the CHT graph. Select Analyze and Cylinder Temperatures from the menu. Write down the average cylinder temperature. Now find and select the range of data where only the secondary ignition system was on. In this example, this is indicated by a change in the altitude bug to 2,500 feet. The range ends when the altitude bug is changed to 3,000 feet. Save this range using the name second test, secondary on, primary off. Select Analyze and Cylinder Temperatures. From the menu, write down the average cylinder temperature. We see that the cylinder temperatures are almost identical between the two tests. Therefore, the secondary ignition timing for this engine is correct. If the temperatures are significantly different, consult your engine manual to determine the corrective action. Thank you for watching. Visit jazzflyer.com to learn more about the Flight Data Viewer.